Example 17. Use the Pythagorean identity to prove the following. Now, these are two other Pythagorean identities, and sometimes if you see Pythagorean identities listed, you would see all three of these. The main one is sine squared t plus cosine squared t equals 1. These are just two offshoots of that original identity. I'm doing this example to both show that is the case, that first identity leads to these two other ones, but I'm also showing two general methods that we use to do proofs. How you choose to go about doing a proof is up to you. There's different methodologies in a given circumstance, so there could be several different ways of doing a proof and with using trig identities. So don't necessarily think that seeing one way makes other ways potentially wrong. It's just a different method. Some methods might be shorter and more to the point than others, but as long as your all the statements you're making are correct and it leads you to the right conclusion, then it's a good proof. One way that we can sometimes take care of doing a proof, first I'm going to work under these premises. That if I know something like, for instance, like the cosecant of t equals 1 over the sine of t, then if I square the cosecant of t, then I'm going to be squaring everything on that right-hand side as well. And this works for any other identities, so like cosecant, secant, cotangent, the tangent of t equaling sine over cosine, and tangent squared would be sine squared over cosine squared, all that stuff. So when I work under those premises, for part A, one way of dealing with it is I could change both sides of the equation until I get the exact same thing on both sides. So what I'm doing here is I'm changing cotangent squared of t to cosine squared t over sine squared t, and I'm changing cosecant squared t to 1 over sine squared t. Another premise we often work with is, since a lot of the identities, the basic identities, are usually written in terms of sine and cosine, it's usually a good idea to take anything that's not written in terms of sine and cosine and rewriting it so that it is. So that's another premise I'm working under here. On the left-hand side and on the right, I'm going to multiply both sides by sine squared t. I could treat something that I don't know necessarily as an equation to make sure it's carried through, and if it carries through correctly, then I know it was an equation to begin with. If I find that it doesn't work, then I know it wasn't really an equation. So if I do that, I get sine squared t plus cosine squared t equals 1. Well, we know that's an identity. We were already told that identity. So that is true, and therefore I've done my proof. So that's an instance where we change both sides of the equation. I could have also rewritten 1 as sine squared t over sine squared t, just to have something with a common denominator, carried it through to get, and then notice that I have sine squared plus cosine squared on top, which becomes 1. And I would end up with 1 over sine squared t on both sides. So there's different ways of handling it. This is not the only way to do this proof. So you have to keep that in mind. That's why when you do proofs, and they say prove the following, you have to show work. You have to show what you did to justify that answer, because the work is the answer, not the final result. Another way of dealing with it, as I do part B, is to start with one side and keep reworking it until I get to the other side. So I'm going to start with tangent squared t plus 1. I can rewrite tangent squared t as sine squared t over cosine squared t. Then what I could do in order to carry through this addition is rewrite 1 as cosine squared t over cosine squared t, just so I have a common denominator. If I carry through that addition now that I have a common denominator, I end up with the sum of the sine squared of t plus the cosine squared of t on top. I end up with the cosine squared t on the bottom. The sine squared t plus the cosine squared t, again from the identity that we're assuming to be correct, would be 1. So I have 1 over the cosine squared t. And 1 over the cosine squared t would be secant squared t, which is the right-hand side, which is where I wanted it to end up being. So that proves the statement. So there's different methodologies of doing these proofs. That's why, again, it's important for you to show your work on these. You have to show your work in order for it to be a legitimate proof. Another proof right here, prove that, this is not an identity that you have listed anywhere. And another thing you have to keep in mind, if you're asked to prove a specific identity, they say, prove this Pythagorean identity. You cannot use that Pythagorean identity to prove it. Excuse me. You cannot use a theorem or an identity that you're trying to prove as a reason for its own proof. That's bad. That's bad proof technique. So keep that in mind, because I think there is a question on web work or I don't think there's a question on web work, but there's some practice questions I think from the textbook that come from your syllabus that say prove this identity, and I'll also say, well, I'm gonna use that identity to prove it. Well, yeah, it's been proven before, but you should know how to prove it. So this one here, I want to prove that sine squared t plus cosecant squared t plus cosine squared t minus cotangent squared t equals 2. First thing I'm going to do is I'm going to rearrange it. Sine squared t plus cosine squared t plus cosecant squared t minus cotangent squared t. I'm allowed to rearrange this by the associative property of addition. Doesn't matter which order I add things, and I'm considering the subtraction as adding a negative, so it doesn't matter which order I carry through additions and subtractions, as long as, you know, they all get done and I'm subtracting the same thing for the subtraction. I know from the previous Pythagorean identity that sine squared t plus cosine squared t equals 1. I don't have an identity for cosecant squared t minus cotangent squared t written as such, but I do know there's an identity that says that 1 plus the cotangent squared t equals cosecant squared t. And if I rearrange that identity a little bit, which I'm also allowed to do, subtracting cotangent squared t from both sides, because that's a subtraction property of equality, I'm allowed to do that for any equation, I get that cosecant squared t minus cotangent squared t would also equal 1. So I can replace this with a 1 over here. And of course, 1 plus 1 does equal 2. So that's my proof. So again, the things you're going to be asked to prove should not take you long periods of time and numerous steps to do. If you go a certain direction, that might take you a lot of steps to do, and it doesn't make it wrong. What I'm just saying is, if you're asked to do some sort of proof on a test or a quiz, and it seems to be taking you a good bit of time, you're probably overcomplicating it. And probably wasting a lot of time on your test and quiz when there's a much easier way to handle it. So look over some of the other identities to see if you can apply those.